So, it has been a while since I have done an Argyle update. A lot has happened. You wouldn't think so because it's been so long and I should have had a lot to talk about. But I got distracted, as I'm apt to do. Shiny objects and whatnot. I wouldn't say it's a pure shiny object, okay? So I've been developing Argyll with Claude and Codex, and what I was finding is that my workflow was just poop. I was not happy with having to switch back and forth between VS Code and the terminal and stuff like that, and so I decided, well, why not just build my own editor? And so I did. I'll talk about that at a different time. We're here to talk about Argyll today and some of the changes. So let's just get into that. We're here. We see the screen, right? One of the things that you'll immediately probably, well, maybe you won't notice it because why would you? But one of the things that you would notice maybe is that the top bar is gone, and because the top bar was just completely wasted real estate. It was real estate that you could otherwise use to sort of scroll into your flows and diagrams and stuff, rather than having the white bar just across the top displaying absolutely nothing, right? And so I got rid of that. Now there's just sort of this little hovery thing where you can select your flows and search flows and stuff like that. So if I go and bang bang bang, there's one of the flows that I've run in the past. Here's one of the failures, and then I can go back. So there's that. This little legend here, I've made it vertical instead of horizontal. It's whatever. I just felt right to do so I did it. The more important things are going to be in the step editor. There's been some considerable change in the step editor. So here we are. As you might recall from the last time, if you watched the last videos, I wouldn't expect you to, but you can. We had the ability to do like sort of collection policies or strategies for attributes, and the way that I was sort of cycling through them was much the same way as that I would cycle through the attribute types, which was dumb, if I'm being entirely honest, right? So the previous mechanism was that you click the button and it would cycle to the next type. And then if you wanted to understand what it was, you had to wait for the hover to understand what you had just selected, which is the stupidest user experience that I could imagine. And so what I've done is I've actually made these all into drop downs. So you could explicitly decide what you want to do with that value. Same thing for attribute types. So you now know what the attribute types are before you actually select them and not afterwards. So it makes it a little bit easier, just like less friction in the user interface. Down here in the HTTP configuration, you're going to notice that there's a new URL type or endpoint type, and it is called the compensate URL, which I'm going to get to later. But effectively, what we're talking about is flow and step compensation when a failure occurs, which is valuable. I've also added some icons. It's fine. It's what it is. Yeah. Another big thing that you're going to notice if you used it, and I apologize if you did use it. I thought about it a long time, and that was that I removed ale from Argyll altogether. And if you don't know what ale is, it's a scheme environment compiler for hosting in Go that I wrote a while back, and that I like. It's an immutable language. It's kind of fast. It runs on inside of a VM, and it would have been perfect for some of the types of stuff that I'm trying to achieve with Argyll steps. But nobody knows Scheme, and what they do know is Lua. For all its warts, Lua is basically ubiquitous, and if you've worked with Nginx or whatever, you've worked with Lua, and so I decided that was going to be it. Lua is going to be the scripting language. For predicates, we still have JPath because it's just a pure expression language for being able to quickly determine if something should proceed or not. But you could also do it with Lua as well, and so that's some of the changes to the UI. Not much else, as I recall. There are some things that we'll get to when we get into compensation later, but those are the major changes to the UI in the meantime. So yeah, I'll go back out, and now let's let me remind you what it looked like to build a step in Go on Argyll before, and so that you can understand the reason for the next major change. So I'll go into the editor. This is a step step plumbing, I would say, and a handler for the way you used to do things in Argyll with Go. And the idea there is that you have a main, you basically actually do the work of creating a client to Argyll, meaning you connect to the Argyll server and you explicitly say, hey, I've got a step for you that I want to register, right? And then so you would create the new step, you would give it a name, you give it all the labels, you would declare individually each of the arguments and so on, including optional and so on, with predicates and stuff like that. And then you would tell the server, you would tell it to start, meaning like you would register it, and then you would start your handler based on that. So start is like a dual purpose thing. It registers the step, and then it immediately starts your handler callback. And the handler was basically this, right? It's a handle function. It receives a context as well as your Argyll args, which is basically just it's basically a map. If you were to look at it, I'll dive into it just so you can see. It's a map of name to any. That's it. And then it returns args, which again is a map of name to any, and then you optionally can return an error. And what that means is that you are doing a lot of boilerplate in order to like coerce values and so on, which is a huge pain in the ass, to be honest. I mean, it works, and it definitely, it's something you could do if you're doing a lot of like code generation, right? Who cares? Just generate massive amount of code that nobody could read, and this is the way that things were done in Argyll before. All this work, look at it all this work before you even get to doing the thing that you're trying to do. And that was one of the big problems with the way Argyll was doing things before, as far as the SDK was concerned. And so I introduced a Go code generator for Argyll, and the idea with that was that I could take all that boilerplate and just get rid of it. It's basically your standard / go.generate. You put it in your package doc file or wherever within a package, and then it's just going to recursively find all of the functions in your packages that have the Argyll marker, which in this case is in this case it's Argyll step. There's also Argyll wrap, so I'll talk about the distinction between the two of them. And at that point you're really like just it's not decorating, right? It's just sort of marking up the function itself. The function then just gets notification args in this case, and then optionally returns an error. Now, in the case of the notification sender, it's sort of a terminal step, right? So it doesn't return anything. It doesn't yield any outputs. And so the only thing it could possibly do is return an error. And, if I dive into notification args, you're literally getting a payment result, which is a struct. So we can do recursive marshalling, which is important. You're getting a reservation as an arg. You're also getting user info as an arg coming in. And so it's kind of neat in that you can just give it real Go structures. Now, let's talk about the distinction between the two. So Argyll : step basically says it is one input, one output, and optionally an error. Or actually, no, one input, not even necessarily one input, and zero or one outputs, and so on. Because you could also have source steps, which are basically providing values but don't receive any values, like timers and stuff like that. So there you have that. Anyway, much easier, right? You're noticing that like all of the boilerplate, it's not there. It's almost immediately just getting into business logic. For example, what's my preferred method for doing notifications? Is it email? Is it SMS? Is it webhook? That's it. You've now just eliminated all of the marshalling because that code is being generated for you, and so your functions start to look sensible, right? They don't look like a huge mess anymore. Now, it could be at some point that I also start to generate like telemetry and logging code. Right now, I'm still doing the explicit S logging, but that's something that I may be able to improve on in the future. I don't want to go down a path where I make one choice that I think is the right choice for doing those kind of functions, and then it turns out that 80% of the people who want to use Argyll call it a deal breaker that's the way that I did it. So I'm gonna just leave that choice to you for now. But in the meantime, it's a lot less code. It's much better to look at. I'm gonna jump into the docs for Argyll now, just so you can kind of see what I'm talking about. The step generators is basically doing a go generate, and let me make this bigger for you. And that's it. You say go generate, go run GitHub, blah 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 blah, and you basically recurse into your packages, and it's going to just generate all that code for you. And here's your basic risk args, risk result, takes args, it returns a result, and it happens to just be that these are the fields. The convention is that in Go, when you export a field, you have to use basically camel case, like uppercase camel case. I convert field names into snake case. And also one of the other things would be like the function name or the step name in this case is going to be converted into kebab case, because those are the conventions that I've used so far with Argyll, and it's for me, it's just easier. I don't have to explicitly say that this is what I want the name to be, but you can override those things, especially in the case of fields, which I'll get into. Now, the next thing that you haven't seen yet, and it's probably important that you see it, is that there's also something called Argyll wrap. And what Argyll wrap does is you give it any function, like any function that you have available to you. You say Argyll wrap at the beginning of it, and it's just going to go and create all of the marshalling code for you, right? And so in this case, calculate risk as an example. Calculate risk takes customer ID as a string and an amount as an int64. It returns a score, an approved, and an optional error. And what Argyll is then going to do is it's going to go and create a step definition based exactly on that, of course, with all the conventions that I've talked about around camel casing and snake casing. You can override how it generates the names, because one of the things in Go is that this is not how Go programmers usually declare their return values. Usually they're just going to declare them as types and then return them explicitly, positionally. There's some cases where you wouldn't do that, where you want to return and you'll have already set the return value by name. But you don't see that often in Go. And so it's nice if it's here because it can use that information to do its naming. But you might also need to give it some help. So if you have a function that looks like this, which is more typical, right? It returns an int and a bool. What's that mean? I don't know. You have the ability to just explicitly say, I'm going to wrap this, and its return results are going to be named score and approved, pretty much. And then it's going to do its work, and it's going to actually create all the same bindings that I just showed you. You can also do it for the inputs. So for example, here, customer ID, normally it's going to make that into snake case, but you can explicitly say, for whatever reason, I want this to be kebab cased as customer ID, right? And so you get some power over how it wraps things. Argyll supports labels. The idea is you have metadata on a step that you could use for documenting it and for searching for steps and stuff like that. In this case, for example, the example that I gave is here's a description of what this step is, score a customer for risk, very contrived. And then you can even identify the domain within the company where that step lives for whatever bookkeeping reasons that you might have. They're arbitrary. You could just give it any label you want. It's marshalling to JSON because that's how Argyll does it. And so the idea there is that because it's a generator, I'm not using reflection to take these structs and convert them to JSON. It's actually pulling in the abstract syntax tree from Go, and it's using that information to create marshallers using the JSON text package, which is part of the Go 1.27 standard library now. So is it faster than reflection? I think. Is it super fast? Probably not. But good enough. And we're talking about HTTP services here at the end of the day. So this is the least of our problems. You can tag fields, like I think I alluded to, and that means that for currency, that could be your internal exported field name in Go, but you could also explicitly say, much like the JSON field tags, that I want it to actually be called ISO_currency when it's published as a step in Argyll. You also have the ability, much like the JSON marshaller in Go, to say, I don't actually want this field to be part of the input arguments in Argyll, so it will just skip it. So you have some power over these things. Now, one of the things about the attributes is that I think I showed you before is it's any types, and it will do the work of creating the proper codex for marshalling them in and out. And it also supports pointers as well. So it'll do the work of creating like an instance and what's the word for this? It's not hydrating, but I guess it kind of could be. But basically marshalling it properly into a newly instantiated instance in Go. Oh, and yes, it supports recursion as well with references. So, just in case you ever did that, it's actually possible to do. Obviously, the problem with that is that Argyll itself is not going to do anything with that information. It's for your own purposes, so you have to do with it what you will. Now, failures, the way it works is like you already saw that you can optionally just add an error to the return result of your functions, and that will be surfaced as an HTTP error using the standard Argyll builder. You can also panic from your functions. Obviously, you shouldn't really do that. It's frowned upon in Go. But if you do, what ends up happening is that the invoker will catch that panic, and then it'll surface that as an HTTP error as well. So, it keeps the service up if something bad happens. The generated output is going to go into a file called zz_argyll _gen.go. So, it keeps it at the end of your list. It's kind of I think it's a Kubernetes sort of thing. To throw it there, so it's sorted at the end of things, and nobody would ever in any kind of a sane world decide that ZZ is the prefix that they want for a file name anyway. So I think it's pretty safe from clobbering your stuff. And then what it's going to do when it generates that code is it's going to create a function called Argyll steps. And what that is it's just returning all of the step definitions that it just generated for you. And then you can use that in order to register it with the server. And so I'll show you what I mean, because that code does exist. Do I have that buffer open? Yes, I do. Good. So, the idea is like this is one of the generated files. As you can see, it's exactly what you would expect. And in this case, since there's only one step that it's defining, your Argyll steps basically returns the notification sender step definition. So, if I go to that, it's here. And it has an ID of notification sender. Again, this is based on the convention, so it's going to be kebab cased. It's going to also convert the name of the function into a name, including taking the space, putting a space in there and stuff like that. So you don't even have to think about it. If you sort of use straightforward conventions about these things, it's gonna do the right thing. By default, it's a step type sync, meaning it's a synchronous HTTP step. I have not implemented asynchronous yet. I'm still thinking about like the ergonomics of long-lived processes where you eventually call it back, and it has to be sort of done in a way where you don't really know that it's an HTTP call. And I'm not going to commit like bullshit to the repo in the meantime with my best guess of what that should be. So I'm going to put more thought into it before I actually implement async. So for right now, it's just synchronous HTTP steps, which is good enough. Here are your labels. And as I mentioned, you get to define the labels using the decorators. They're not decorators. The markers. So if I go back, where is it? Oh, it's over here. So yeah, there are all your labels which you defined, right? And so if you go back into the generate code, you're going to see all those there. Actually, I'm going to just do this. So yeah. Domain notifications in this case, you can see it, right? And it's an example in this case. So like you just have that. Here are your generated attributes: payment, result, reservation, user info. As far as JSON is concerned, it's an object because that's the best that JSON can do right now. I may support JSON schema in the future. Again, this is one of those things where I don't know if I want to commit to that and then have someone say, but why don't you use Avro instead? So for right now, I just call it that, and you deal with validating things on your own. I'm sorry. And then finally, the handler, right? And that is a synchronous handler. And then the idea is that you have your callback here, and it looks exactly like what you would expect, pretty much. So yeah, there you have it. I mean, that's the generator. Now let's go into the thing that I was looking at earlier, which was compensation. So, as you saw here, let's look at stock reservation. There is a compensate URL here. And, what compensation is ultimately is that if a step fails, or actually, even if it succeeds, depends on whether or not it's sort of an individual step that needs to actually roll back based on partial failure, or whether it's a flow that needs to roll back if the flow itself doesn't achieve its goals. So that's what we mean by compensation. I hesitate to call it the saga pattern because it's used in these two different situations. And so for now, I'm just going to call it compensation. Okay, so two modes for compensation. As you might know, Argyll supports a single step having many work items, meaning like the step could take an array of things, and based on that array of things, if I say, hey, this is actually needs to be, I'll show you what I mean. This actually needs to be done in multi-mode, right? So it takes the array and then it creates a work item for each item in that array, and then actually invokes the endpoint for each one in up to some parallelization limit. So it actually will parallelize it if it can. You can draw that back, but it's defined at the server level. Now, what ends up happening at the step level is that if any one of those things fails right now, there's just a blanket policy that says, sorry, the step failed because one of the work items failed. That may change in the future, but for right now, that's the policy. And what ends up happening if you have a compensate URL is that for all of the successful work items, it's going to roll those back by invoking the compensate URL against those tokens. And so, the idea there is that you don't end up with like a partially complete step or partially complete work in the case of failure, basically. Now, the other way that compensation comes into play is that if you wanted to start a flow, like in this case, I say notification sender, right? And I say compensate. What I'm indicating to Argyll at that point is that if I do not achieve this goal of reaching the notification sender successfully, any of the steps that are part of the flow up to that point who have a compensation URL need to actually compensate themselves. So, it used to be that the terminal state of an Argyll flow was when the goals were achieved or when they failed, right? That was it. Nothing happened after that. That has now been extended to having sort of a compensation group before the flow is actually fully deactivated. And so I'm going to demo it. And again, because this is stochastic, I can't guarantee it's going to happen on the first try. But the way that it should work is that I'm going to invoke the flow with notification sender, and then payment processor fails like at least half of the time. That's intentional, but it's simulating, payment gateway failures and declinations and stuff like that. And then if it does fail, it's supposed to roll back stock reservation. And it could well be, and it's a good example, that stock reservation succeeded before payment failed, right? And then you'll be able to see the flow to that where we just ensure that stock reservation actually gets compensated. So I'm going to run it. It might work the first time. We'll see. Again, Argyll will parallelize things wherever possible, and so these are done in waves. And compensation is also done in waves, but in reverse, whenever there are compensate URLs. So that succeeded. Stock reservation is active, right? It's doing something with its fake latency, and payment processor fails, and now you can see that it is reversing, compensating. And it is now compensated. So, you know, I could also make it succeed, but you've seen this succeed in the past, so I'm not going to bother. But the idea there is that if the goal can't be achieved, it still could be an independent payment processor could fail, and it could be that there's an alternative way that we've modeled the flow that makes it succeed even though notification sender failed, but it's always based on the goals. And so in this case, the goal of notification sender failed, and therefore compensation is triggered. Now, what does that look like? So I'm going to go into Docker so you can kind of see exactly what happened. I already have stock reservation open, and so you can see, you know, there's two sets of calls. There's the attempted stock reservation call. That's the initial call to stock reservation when it did succeed. And, you know, you have stock reserved. That's the event. Like, hey, this succeeded. Stock for whatever this item was, product ID, prod laptop, it's reserved for a quantity of one. Started at 46 items and it went down to 45, right? And that would have been the end of the story if it didn't have to compensate. And now what ends up happening is you get this subsequent set of calls where you're asking it to do a stock release, and, you know, with the same SKU and with the same reservation ID, like everything from an item potency point of view, including the flow ID. And it is now going to release that stock, and you're going to see it go from 45 back up to 46. So that's it. That's the idea of compensation. And like I said, it's performed in reverse order in waves, right? So, you know, the idea is like you want to make sure that you clean up the most recent thing, because quite often that recent thing was predicated on something else having been done before that, and that will also have to be cleaned up if it has a compensator. Some limitations, of course, you can't compensate on a memoized field, memoized step, because it doesn't make sense. You know, the idea there is like if a step is memoizable, what you're basically saying is that it doesn't have side effects, right? And so that the end result would be that it just ends up the way that it is, and you can remember that value later, which means that compensation is not possible in that situation. And vice versa. So if I give this some bogus value, I can no longer memoize it. So those are some of the rules. But yeah, that's it. Anything else? No. That's it. Those are some of the major things that have happened in the past couple of months. Continuing to work on it, specifically continuing to work on the Go generator, which I think is I'm not going to call it a game changer, but it's a really good ergonomic introduction to the system, and I'm pretty happy about it. So yeah, with that, I will see you next time. Thank you.